Continuing from our previous video, one question that arises from integration is, given the derivative of a function f prime, can we find the function f? For example, suppose we are given the function f prime of x equals 2x minus 1, and we wish to find f of x. We now know we can find f by integrating both sides of the equation. So f of x equals the indefinite integral of f prime of x dx, which is the indefinite integral of 2x minus 1 dx, which is x squared minus x plus c, where c is an arbitrary constant. There are infinitely many functions that have the derivative of f prime, each differing from any other by its constant. The equation f prime of x equals 2x minus 1 is called a differential equation. A differential equation is an equation that involves the derivative or differential of an unknown function. A solution of a differential equation is any function that satisfies the differential equation f of x equals x squared minus x plus c, gives all the solutions of the differential equation f prime of x equals 2x minus 1, and is called the general solution. The graphs of any solution to a differential equation have one property in common. For any fixed value of x, the tangent lines to the graphs have the same slope. This follows because any member of the family f of x equals x squared minus x plus c must have the same slope at x, namely 2x minus 1. Although there are infinitely many solutions to the differential equation f prime of x equals 2x minus 1, we can obtain a particular solution by specifying the value of the function must assume a certain value of x. For example, suppose we stipulate that the function f must satisfy the condition f of 1 equals 3, or equivalently, the graph of f must pass through the point 1, 3. Then using the condition of the general solution f of x equals x squared minus x plus c, we find that f of 1 equals 1 minus 1 plus c equals 3, and c equals 3. Thus, the particular solution is f of x equals x squared minus x plus 3. The condition of f of 1 equals 3 is an example of an initial condition. More generally, an initial condition is a condition imposed on the value of f at x equals a. An initial value problem is one in which we are required to find a function satisfying 1, a differential equation, and 2, one or more initial conditions. For example, find the function f if it is known that f prime of x equals 3x squared minus 4x plus 8, and f of 1 equals 9. First, integrating f prime of x, we find f of x equals the integral of f prime of x dx, which is the integral of 3x squared minus 4x plus 8 dx, which equals x cubed minus 2x squared plus 8x plus c. Using the condition f of 1 equals 9, we have x equals f of 1, which is equal to 1 cubed minus 2 times 1 squared plus 8 times 1 plus c, which is 7 plus c, or c equals 2. Therefore, the required function f is given by f of x equals x cubed minus 2x squared plus 8x plus 2. In a test run of a maglev along a straight elevated monorail track, data obtained from reading its speedometer indicate that the velocity of the maglev at time t can be described by the velocity function v of t equals 8t for 0 less than or equal to t less than or equal to 30. Find the position function of the maglev. Assume that initially the maglev is located at the origin of a coordinate line. Let s of t denote the position of the maglev at any time t for 0 less than or equal to t less than or equal to 30. Then s prime of t equals v of t. So we have the initial value problem s prime of t equals 8t and s of 0 equals 0. Integrating both sides of the differential equation s prime of t equals 8t, we get s of t equals 4t squared plus c, where c is an arbitrary constant. To evaluate c, we use the initial condition s of 0 equals 0 to write s of 0 equals 4 times 0 squared plus c, which equals 0, or c equals 0. This would give us the final equation, S of t equals 4t squared, which I think fell off the bottom of the page. Sorry about that. The current circulation of the Investor's Digest is 3,000 copies per week. The managing editor of this weekly projects a growth rate of 4 plus 5t to the 2/3 copies per week, t weeks from now for the next 3 years. On the basis of her projection, what will be the circulation of the digest 125 weeks from now? Let S of t denote the circulation of the digest t weeks from now. Then S prime of t is the rate of change in the circulation in the tth week and is given by S prime of t equals 4 plus 5 times t to the 2/3 power. Further, the current circulation of 3,000 copies per week translates into the initial condition S of 0 equals 3,000. Integrating both sides of the differential equation with respect to t gives us S of t equals the indefinite integral of S prime of t dt, which is equal to the indefinite integral of 4 plus 5t to the 2/3 dt, which is equal to 4t plus 5 times t to the 5/3 over 5/3 plus c, which is 4t plus 3t to the 5/3 plus c. To determine the value of c, we use the condition S prime of 0 equals 3,000 to write S of 0 equals 4 times 0 plus 3 times 0 to the 5/3 plus c equals 3,000, which gives c equals 3,000. Therefore, the circulation of the digest t weeks from now will be S of t equals 4t plus 3t to the 5/3 plus 3,000. In particular, the circulation 125 weeks from now will be S of 125 plus 4 times 125 plus 3 times 125 to the 5/3 plus 3,000 equals 12,875 copies per week.